Hi, and welcome to 2.6 and 2.7. So I combined two sections, but I'm going to take 2 days. It just is a better way to go about it. And so in class, we did some marker board review, but we're still going to be okay even if we don't do the marker board review if you're learning it through the video. So go ahead and get out your packet, get to the notes, 2.6 and 2.7, rational functions. So whoops, we okay, hope you didn't see that. So this looks different than polynomials, right? Because we've got an x in the denominator, and that's our tell that we're dealing with a rational function. When we're dealing with a function that has an x in the denominator, then we know, oh, it's not a polynomial, it's a rational. And rational functions are a lot of fun. I think you'll enjoy graphing them. And so in your packet, you'll see that we have steps. And so we're going to go ahead and look at step number 1. My steps are on the next page. So step number 1 says find the vertical asymptote. All right, how do we find the vertical asymptote? We set the denominator equal to 0 and solve for x. So let's think about why we would want to do that. Thinking about this fraction, wouldn't we have some trouble if x was equal to -3? If x equaled -3, we'd have a 0 in the denominator, right? Like if we were making a table, let's pretend, I'm not doing the vertical asymptote yet, I'm just trying to set it up. If we were making a table, we'd put 1 in, let's see, that'd be 2 minus 1 is 1. 1 plus 3 is 4, 1/4. Oh, we're doing so good. All right, let's put -3 in. So that would be -6. So -7 over 0. Oh no, right? That's undefined. We don't know how many zeros are in -7. We can't answer that. What do we put there when we graph -3? How can you plot -3 comma undefined? And so when we're dealing with rational functions, that means that we have a vertical asymptote there. So with step 1, we're always going to set our denominator equal to 0 and solve. And look, it gives us x equals -3 is a line that goes straight up and down, right? This is our vertical asymptote. So we literally go to the graph, we look at the x-axis, we find -3, and we put a vertical asymptote in our graph. And this vertical asymptote is going to help guide us, just like when we did exponential and logs, right? We used asymptotes then, so you know what they're about. All right, so step 1, check. Every single time we see a rational function, we're going to do that first. We're going to set our denominator equal to 0 and see where we have a vertical asymptote there. And we have one there because the function is undefined when x is equal to -3. All right, let's look at our second step. Second step is find the horizontal asymptote. Now you'll notice we've got 3 ways to go about this, all right? Depending on what rational function we're looking at, there's 3 different rules. So we're going to be looking at the first rule because this says the highest powers and top and bottom are equal. So that means, right, numerator and denominator are equal. Then we're going to use this rule. So if the highest powers and the top and the bottom are equal, our horizontal asymptote comes from the ratio of our leading coefficients. So we know what those words mean, right? We've used leading coefficient before. And so what that means is this. Is x and x, are those raised to the same power? Absolutely, right? It's the first power. So when our highest power, which is 1 in the numerator, is the same as the highest power in the denominator, 1, then our horizontal asymptote comes from the ratio of the leading coefficients. So we know that 2 is the leading coefficient for 2x. And then let's put a little 1 in here to remind us that there's also a leading coefficient in front of the x. And so our horizontal asymptote is going to be found from this ratio. Ratio is just a fraction, right? So let's start our, let's use purple. Let's start our step 2. We know that our horizontal asymptote is going to equal 2 over 1. And you know what? Which is 2. But let's stop and write it the same way. Like our vertical asymptote was the line x equals -3. So our horizontal asymptote is the line y equals 2. Right? Because these asymptotes are really lines. So that means go to the y-axis, Find the 2, and let's put our asymptote in. And you're probably like, ooh, both a vertical and a horizontal? Or maybe you're not thinking that, but yay, this is always a good thing. When we have a vertical and a horizontal asymptote, it makes sketching the graph so much easier, and you'll see why in a second. All right, so if I were you, since this is new, I would maybe pause and rewind a little bit and listen to me explain steps 1 and 2 again. But we'll do a couple different examples, and that should help. All right, so step 3, find x-intercepts, find y-intercept. We are good at that, right? We don't need it. That's not new. So the only new part were those, the only new part was step 1 and step 2. All right, I'm going to make my work a little smaller because I'm running out of space already. Hopefully you're good. All right. Whoop. Oh, come on. I don't want that 1 in there. Oh, well, you know what? It's okay. Do. All right, let's make this smaller, and let's go to step 3. Our 1 traveled with us. All right, so step 3, we're going to find our x-intercepts, and we know to find our x-intercepts, we set y equal to 0. All right, now I want to tell you something. Let's talk baby math for a second, so let me change my color. Let's see, what would 0 over 4 be equal to? That's right, 0. 0 over 100, 0. 0 over negative 33, 0. So what makes a fraction equal to 0? The fact that the numerator, the top, is equal to 0. The denominator doesn't matter. I mean, of course, unless the denominator was 0, that would be terrible. That is not 0. 0 over 0 is not 0. It's actually what's called an indeterminate form, and it's undefined. All right, so here we go. All we have to do to find the x-intercept is set the numerator equal to 0 and solve. I don't know why I did it that way, but I did. All right. If you put your 0 on the other side, we both would have come up with 1/2, right? All of us. All right, that means go to the x-axis, find 1/2, put a little dot. We're doing so good. All right, do you all remember how to find the y? So noisy. People are, let's see, I don't know if you're going to be able to see that. Let's do this. Okay, so let's find the y-intercept. So the y-intercept is where we make x equal to 0, right? So we're going to plug 0 in wherever we see x, and we get what? 2 minus 1 is 1. 1 over 3 is 1 over 3. So let's remind ourselves that's the y-intercept. Okay, it's not a line, it's the intercept. And let's go back to our x-intercept. Remind ourselves that's an x-intercept. All right? All right, so let's go ahead and look at the y-axis and find 1/3. Is it positive 1/3? I'm just double checking my work. If I plug 0 in, that's negative 1 over 3. Whoops. Negative 1 over 3. You're probably yelling at me through the screen. Is it over me? You forgot your negative. I did forget my negative. All right. So so that's going to be negative 1/3. And so we'll go to the y-axis and we'll put a little negative 1/3. Once again, it's just a sketch. It is just a sketch. All right. So far, so good. Let's look at our 4th step. So our 4th step says make a table. All right, and then we're done. So, woo! This is going to be good. So I want to tell you something. You know, these horizontal and vertical asymptotes are kind of like gates where, or maybe not gates because you can see gates, but more those electric things buried under the ground where dogs, when they're wearing that collar, they know, like, oh, can't cross over that. This graph knows I can't cross over. And as I'm saying that, sometimes in the middle of a graph, like close to 0, a graph will cross through the horizontal asymptote. I think we might see some of those, I'm not sure, but usually they don't, and this one's not going to. And so here's what we're going to do. We see these 2 points, and we're going to know that an asymptote means we're going to get really close to it, but we're not going to cross it. So I'm going to go to my sketching part. Let's see, what should I use for a sketch? Something you could see. And I'm going to sketch. I'm going to start with these 2 points. I'm going to sketch. Woo! Does not look good. So there's an arrow there. And then I'm going to do the same thing going this way, though. So like that. All right, so I've got part of the graph done. Now, I've got the part from to the right of the horizontal asymptote, but we need to make a table because we don't know what happens to the left side of the vertical asymptote, the green asymptote. So let's go ahead and find that. Let's go ahead and do what I haven't used. So step 4, we need a table, and we need a thinner line. All right, so we can pick any number to the left of -3. So we could pick -4, we could pick -5. Let's just go with -4. So let's plug in -4. I'm plugging it back into our original function. So I'm going to get it what? I'm going to write it down so if I make a mistake I can see. So I'm going to get -8 minus 1 over -4 plus 3. So right, -8 minus 1, I'm not trusting myself after my mistake. -9 over -1 is 9. All right, do you agree with that? Hopefully that is what you got as well. So with -9, I'm going to go to -4, and I'm going to go all the way up. I'm sorry, not -9. I'm going to go -4. I'm going to go all the way up to +9. And this tells me what side of the vertical asymptote I'm on. I'm on the left side. Now, I don't need to do any more points. Do you know why? Because I know how our graph acts because of these horizontal and vertical asymptotes. We're going to go really close here, and then woo, up like that. And we're done. Yay! I told you rational functions, graphing rational functions, pretty fun. And so, all right, the new part was step 1 and step 2, finding the 2 asymptotes. Let's answer these questions down here. All right, so our vertical asymptote, right, we already did this. Do we need to really do it again? Yes, because you're going to see this. I think this is how I have the test set up. So let's just get used to it. So our vertical asymptote was at x equals -3. We didn't have holes. We'll cross through that. We'll talk about that later. Horizontal asymptote, we had that at y equals 2. Slant asymptote, that comes later. This one didn't have. This, I'm not just skipping it. This function, this rational function didn't have a hole, and it didn't have slant asymptote. X-intercepts, what was it? 1/2, and the y-intercept was -1/3. All right, whoops, I made an additional point. I didn't even notice that. All right, woo, let's do it again. Let me look at your packet. How many more do we have? Let's do this next one. And here we go. Step 1. We're going to find the vertical asymptote. So we're going to do that by setting our denominator equal to 0. We're going to factor. What are we going to need? -3 plus 2, right? Set our factors equal to 0. And then we find our zeros. Well, they're right. They're not the zeros this time, but when we set our factors equal to 0, we're like, wait, what are we doing? Is these our x-intercepts? No. These are when we set our denominator equal to 0. These tell me that we have, oh my gosh, we have two horizontal asymptotes at x equals 3 and at x equals -2. So let's go ahead and put those in. Let's see, we'll put it at 3 and -2. So this is going to be fun. Okay. I used way too much space there. All right, so let's go ahead and find our horizontal asymptote. Now, you'll notice that they are not the same power, right? X squared, that square is bigger than x to the first power. So there's a second rule for finding the horizontal asymptote. So we're still, our next step is still finding the vertical, did I say horizontal asymptote? Oi, oi, oi. Okay, it's been a while since I've had to make a pre-calc video. I realize if my head's not in the game, I'm gonna make mistakes. Those are not horizontal asymptotes. Were you yelling at me through the screen? Vertical asymptotes. All right, now let's find horizontal asymptotes. At least I draw them as verticals. All right, so let's go back to the rules. So we already did the rule for number 1, right? We used that in the first one. We're going to use the rule for number 2. And this says if your bottom power is the highest, then your horizontal asymptote is y equals 0. Doesn't matter how much higher. If the bottom power is higher, we stop and go, yes, my horizontal asymptote is y equals 0. So yes, this is higher. And so we just stop and say y equals 0 is our horizontal asymptote. Okay? All right, so yes, do we have to memorize these rules? Yes, but you know what? I was listening to some of my students, what was the second block, singing so many songs. They've memorized so many lyrics. I know you have it in you, okay? You can memorize. All right, so we did the first 2 steps. Those were the only new things that we are doing today. So let's go ahead and do the x-intercepts. Let's see. So the x-intercept, we're going to go ahead and set y equal to 0. And we're going to use the knowledge that we don't have to look at the denominator. We just set the numerator equal to 0 to find our x-intercept. Is it the same x-intercept? And why do I keep putting the 0 on the other side? I don't like that. And we can do it, but, right? Let's go ahead and set the numerator equal to 0. So we're going to get 1, and x is equal to 1/2. And so we'll go to the x-axis, we'll find 1/2, and we'll put a little dot there. We're like, yep, we got it. All right, let's find, so that's our x-intercept. Let's go ahead and find our, let's pull some pink out. Let's find our y-intercept. And so our y-intercept is where we set all of our x's equal to 0. All right, what do we get? We get what? -1 over -6. That sound good? So 1/6. So we go to the y-axis, and we find a 1/6. Mine's going to look more like close to a fourth. It's not going to be 1/6 because that's going to be, on your paper, maybe you can get a little bit more accurate. Okay, so this was step 3. Sorry, step 3, because all that's left, right, is to make a table. So here's why we have to make a table. We don't know we don't know a lot of things. All right, I'm going to do a fake sketch because this could look like that, and let's see, that could look like that, and that could look like that, right? That would still be a function, yes. But I don't know if that's that or not. I'm just guessing. This could be like go through the points like this, but still obey the horizontal asymptotes. And maybe we've got one here and one here, right? So we don't know, and that's why we need a table, right? The table is going to help us to know where to do our sketch. So let's get those out because that's not right. Whoop. Where'd it go? Okay, it's gone. Okay. Whew. Okay, no. That was strange. Okay, let's find it again. Okay, it's gone. It's totally gone. Okay, you know what? That really scared me. I'm going to get rid of this the old-fashioned way. Okay. Whew. All right, let's make a table, and I won't mess around anymore because that really did scare me. All right, let's see what our time is. Okay, it's not a short video. All right, so let's go ahead and do a table. I want to check out, I think that it is going to, well, you can't see what I'm doing right now. Let's see what it's doing at x equals 1. That's going to tell us a lot. So I'm going to make my table here so I can see it. Oh my gosh, make it thinner. All right, so when x is equal to 1, I'm plugging it into all my x's. I'll get what? 2 minus 1 is 1. 1 minus 1 minus 6. So I'll get 1 over -6, right? -1/6. So if I'm at 1, I'm at negative 1, 6. Yeah, this tells me, I can already tell because where these 3 points are located and the 2 horizontal asymptotes that keep them in, that tells me that my graph is going to look like this. Woo. Okay, we'll get lots of practice with this. But now I don't know what happens to the left of the horizontal asymptote at -2. What happens to the right of the horizontal asymptote at x equals 3? So I need a table, right? So what's to the left? Why not just try -4? Let's switch that over. So -4. Let's see. I got -8 minus 1, so -9 on the top. And then I've got 16. I need a calculator. Help! 16 plus 4 is 20, minus 6 is 14. Is that right? I should probably pause and use a calculator. Let's see, -4. Yep, that's -9. That's 16 plus 4 is 20. Yep. All right, so once again, thank goodness we're just doing a sketch. So -9 over 14 is bigger than -1/2, right? But really what we were looking for is, are we on the below the vertical asymptote or are we above? That's all we need, that little point, because that tells us that our graph is going to look like this. All right, and I bet, right, our graph's going to be up here to the right, but let's go ahead and try. So let's look at x equals 4. Let's plug in x equals 4. So I'll get what? That's 8 minus 1 is 7, and then that's 16 minus 4 is 12, minus 6 is 6. So 7, 6, that sound right? Yep. So we're going to go to 4, and 7, 6 is a little bit more than 1. But ultimately, I just wanted to know where am I going to put my sketch? Is it going to be above the horizontal line or below it? And it is above. Okay. All right, so what are we doing? We are using our asymptotes, our x-intercepts, our y-intercepts, and tables that fill in the blank of what does this function do given all of these parameters, right? We can't, now, oops, we did cross through, note right here, we did cross through the horizontal asymptote. Sometimes functions will do that, but they only usually do that right in the middle. Horizontal asymptotes are actually more about the end behavior of a function. And when you get to calculus, you'll understand that a little bit more. All right, let's see what else I wanted you to do. Okay. Okay, it says add to blank page in notes. Okay, you'll see this on WebAssign too. It says find any asymptotes and holes in the graph of the rational function. Okay, so this is good because we're not graphing, we're just really focusing on the new stuff. So go ahead and pause this and write it down, and let me show you how to do this since it's on your WebAssign you're going to do in a second, or a few minutes. All right, so asymptotes. First, vertical asymptote, right? We set x squared plus 7x plus 10 equal to 0. We factor. And we find that we have 2 vertical asymptotes, right? So we would say x equals, we'd write -2 comma -5, I imagine. Okay, so then horizontal asymptotes, we're like, oh yes, 2 and 2, they are the same. So when we have our highest powers the same, it's the ratio of our leading coefficient, which is 1 over 1, which is 1. So our horizontal asymptote is y equals 1. All right, here's a new thing, holes. What the heck are they talking about, holes? All right, I flew through the vertical and the horizontal asymptotes, but let's slow down talking about holes. All right, let's go ahead and let's simplify this. Let's simplify the numerator. So if by simplifying, I mean let's factor the numerator. So that's the difference of 2 squares, right? And then factor the denominator. We already did that. And we're going to find out that, whoops, we actually don't have 2 vertical asymptotes. Now, we haven't seen this in graphing yet because I'm trying to make this video short. But if we were to graph this video, we actually wouldn't have two vertical asymptotes. And I'll show you why. See how x minus 2, oops, that's not what I wanted. See how x minus 2 and x minus, I'm sorry. See how, I want this video to be done, don't you? All right, see how x plus 2 and x plus 2 cancel out? That means that the x plus 2 factor does not lead to a vertical asymptote. But what it does lead to is a hole, right? So let's write that down. Let's first of all get rid of, we only have one vertical asymptote at x equals negative 5. All right, so let's write this down. Maybe I can type it up so that it goes better. All right, so when a factor cancels out, that means we do not have a vertical asymptote there. Instead, we have a hole in the graph there. I mean, literally, we will have a hole in the graph, all right? And it will look like, it'll look something like this. Let's see. Where's our hole? At x equals negative 2. So that would mean we'd have something like this. Let's just say, I don't know what this graph looks like. Let's just say, it's negative 2. So let's just say we're coming along this way. We would see a hole, okay? So once again, I'm just making this up. But instead of a vertical asymptote, we literally, what we would do is we'd be that little person walking along the x-axis, and when we got to negative 2 and we looked up, we would see a hole in the graph. Okay? All right, we're going to do more with holes, but I wanted to show you this because they're going to ask you about it. Let's do another one. I think I've got one more. Okay, let's do one more. All right, so pause. Let's just go through this. It's the same exact thing we just did. I want to make sure that you're ready, though, for it with WebAssign. All right, so asymptotes and holes. Here we go. Let's pretend, let's do the first one where I'm sure we're going to end up with a hole, but let's just pretend like, what hole? We don't know. All right, let's go ahead and factor. Now this time we won't, let's see, minus 4 plus 3. All right, so we are not going to go filling in our vertical asymptotes just quite yet, all right? Let's go ahead and stop and, I mean, hot pink for this. Let's stop and factor out the top. Okay, see that 2, everything, ooh, I'm going to just factor that 2 out if that's okay with you, because doing that is going to make it way easier to factor. All right, so let's see. At the bottom, because I've got to refactor anyways. All right, so the numerator is going to be what? X minus 5, x plus 3. Denominator, we have already factored, x minus 4, x plus 3. And yay, we have a hole in the graph. So see how we've got x plus 3 and x plus 3 cancel out? That means because the x plus 3 factor canceled out, that means we don't have a vertical asymptote there. There's actually a hole there. So let's say we've got our vertical asymptote at x equals 4. We've got a hole at x equals negative 3. And then let's find our horizontal asymptote. They're the same, right? 2 and 2 are the same. So 2 over 1 is our horizontal asymptote, which is 2. Whew! That's a lesson. That was really a lesson. All right, we are going to stop it here and then pick up next class with the rest of the notes. But you know enough to do WebAssign. So WebAssign 2.6 and 2.7, day 1. Thank you for joining me, and I will see you in class.